go. Okay, this is part B of section 3.3 quadratic functions. Yesterday we went over vertex form, which they call transformation form. So vertex form makes it really easy to find the vertex. Like this function right here, I look at the 3 and I look at the 4 and I change the sign of the 3 to make a positive 3 and I leave the 4 to be a negative 4, and this is where my vertex is located. If you ever want to find the x-intercept, you just set the y-coordinate equal to 0 and you solve for x. Okay, we're going to be doing that same thing for the next two forms. Okay, so standard form is the next form, polynomial form. This guy right here is polynomial form. An example of that is x squared plus 5x minus 6. This is the form that you are used to seeing for a quadratic function. Okay, if I'm trying to find the vertex, to find the vertex, I do negative b over 2a. Where have you seen that before? The quadratic formula goes negative b, you don't have to write this down, plus minus square root b squared minus 4ac all over 2a. Negative b over 2a is a part of the quadratic formula, right? That's not a coincidence. So when I'm finding the vertex, I do negative b over 2a, and then we'll talk about what this guy means, f of negative b over 2a, okay? I think we did this in algebra 2. Maybe. It's been a while. So let's take this function right here, and then we want to find the vertex. So x squared plus 2x plus 3. That is a polynomial function, or like it's in polynomial standard form. And we want to do negative b over 2a. So let's designate a, b, c. If you need to write this out, go for it. Okay, what is your a value going to be? 1. It's not any x's, it's just the numbers out in front. Okay, b is 2 and c is 3. Okay, if there is a negative, you take the negative with the number. So if there was a negative 2 in front of there, the b value would be negative 2. Okay? All right, so find the vertex. We want to do negative b over 2a. So negative b would be negative 2 over 2 times a is 1. Negative 2 divided by 2 times 1 is just negative, wrong. Negative 1, you're right. Okay, negative 1 comma something. Now, how do I get what this something is? How do I get what that y-coordinate is? I do the second one, which says f of negative b over 2. What does that mean?
Y equals?
I found the x-coordinate.
You plug the whole thing
You plug negative 1 into this equation. That's what f of negative b. This just means f of that just means plug it in. Plug in. So now that I have the negative 1, I plug it into there. So I have negative 1 squared plus 2 times negative 1 plus 3. All right, negative 1 squared becomes positive 1. 2 times negative 1 is negative 2 plus 3. And that is 1 minus 2 plus 3 is 2, I think.
Yeah.
Right?
Yeah.
Now, if you enter it into your calculator and don't put parentheses around the negative 1, it will say a positive 1. Okay, so negative 1 comma 2, that is the vertex. What does a vertex mean again?
The intersection of x.
Nope. Nope.
It's 1 point where it's
Vertex is this point or this point. That's what your vertex is. It's the high or the low point, right? Okay, so negative 1, positive 2, that's where my vertex is located. Okay, so we know that there's my dot. Is this going to be a smiley face or a frowny face?
Smiley face.
How do you know?
Because there's no negative in front of the x.
There's a positive technically understood in front of the x squared. So that's a positive x squared. He's going to smile. Okay, before we graph him, let's find the x and y intercept. So we found the vertex, and then they want us to find the x and the y intercept. I'm going to do that over here. So my function was, I'm sorry, I'm making you guys sick over here. X squared plus 2x plus 3. That's my original function, y equals. Okay, if I want to find the x intercepts, what do? You plug 0 in for, if you're trying to find the x-intercept, you plug 0 in for y. So I'm going to say 0 equals x squared plus 2x plus 3. Okay, and then I want to break down x squared plus 2x plus 3. Is there a number you can multiply to get 3, but when you add them, give you 2?
2 and 1.
Ooh. 2 and 1?
3.
That's not going to work. 3 and 1? But that's not going to work because then that would give you 4 in the middle. Ew. So now what?
Decimal? Would it be a
It's going to be a decimal. So then what does that mean we have to do? Quadratic formula. Okay? Blech. Negative b is negative 2 plus minus square root b squared is going to be 4 minus 4 times 1 times 3. Gross. All over 2 times 1. Okay, before we get going too far, let's get the inside figured out, inside of that square root. 4 minus 4 times 1 times 3. What's 4 times 1 times 3? 12. This says 4 minus 12, which is?
Negative.
Negative. We don't care what the number is. It's negative. The square root of a negative is?
None.
0 with a line. So what does that mean? He doesn't have any x-intercepts? X-intercepts. We were trying to find the x-intercepts, and we got this. Didn't we know this, though? If he's a smiley face, and that's his lowest point that's on my graph, didn't we know that he doesn't have any x-intercepts? Right? He's only going up. Okay? Oh, my gosh. Y-intercepts. How do I find the y-intercepts?
I was thinking. I thought it had to touch them.
Yeah, the y-intercepts. How do you find y-intercepts?
You plug
0 in for x. So y equals 0 squared plus 2 times 0 plus 3. And this is actually really easy. These two cross off, so the y-intercept is 3. So he's going to touch here at 3 on the y. But if he touches there, he's also going to be at the same spot on the other side. Does that make sense?
Yeah.
Okay, so my parabola looks something like this. Perfect. Okay.
So when you're finding the y-intercept, you just plug in 0 for these?
Yep. When you're finding the x-intercept, you plug 0 in for y. When you're finding the y-intercept, you plug 0 in for x. Okay, good? So that is dissecting a polynomial form or standard form of a function. Okay, so when it's in standard form, you have to do those things. Negative b over 2a. Okay, good?
What are our answers?
So the answer is like the graph. The vertex is negative 1, 2. The x-intercept is nothing. The y-intercept is 3. Those purple circled things. Okay, and that results in the graph of that parabola right there. Okay, good?
Yeah.
All right, next. X-intercept form. Okay, so when it's written like this guy, like x plus 3, x minus 2, the reason why this is called x-intercept form or factored form, it's completely broken down. This form is really nice to find the x-intercepts. Because if I plug 0 in for y, and I say 0 equals x plus 3 and x minus 2, what are my x-intercepts going to be? X equals negative 3 and x equals positive 2. That makes it really nice to find those. Yeah? Okay, so I can just go ahead and know that the graph intersects at 2 and negative 3, and he's going to be a smiley face because there's no negative in front. So he's going to do something of this nature. That's what he's going to look like. Okay, good? All right, let's go down and do an example. They tell us up here, it says to find the vertex, you do s plus t and you divide it by 2. It's like finding the average or the middle of these two things. Okay, so if I was trying to find the vertex, I would take negative 3 and add it to 2 and divide that by 2. Okay, so that would be negative 3 plus 2 divided by 2. This would be negative 1/2, comma something. And I would find that something by plugging in, right? So s plus t divided by 2, you just take your two factors where he crosses and you just divide it in half because my vertex, or the low point here, should be halfway between these 2 points right here, this guy and this guy. My vertex, my low point, should be halfway between those two, right? Isn't that the way that should just work? Halfway between those two. So I add them together and divide by 2, and that will give me my vertex. Let's go down to an actual example. X-intercept form. For the graph of the function, we have this guy right here. What? Sure.
Second one?
What?
Negative 1/2.
Comma, whatever you get when you plug it in. I'm not going to plug it in.
Plug what in?
Plug negative 1/2 into the function.
Oh.
Okay. We'll do an actual example here in just a second.
So what would you do? What would you plug negative 1/2 in for s or t?
Right here. You would plug it in
Oh.
to the original function that we had. Okay. All right. We'll go down and do an actual example here in a second. Okay. Good? All right. This is my function that I have. That negative 1/2. Ugh. That doesn't do anything except tell me that it is going down. Michelle's saying it's doing one of these. It's going downhill, okay, because that negative. and the 1/2 makes him shorter and fatter, okay? Which really, whatever, doesn't really do too much, okay? All right, find the vertex and the x and y intercepts. Let's find the x and y intercept first. So the x-intercept and the y-intercept, and then we're going to find the vertex. Those are the three things that we have to find. So x-intercept, I plug 0 in for y. So I have 0 equals negative 1/2 times x minus 4 times x plus 2. Okay? The negative 1/2 doesn't do anything. I just set those two pieces equal to 0. So my x-intercepts are going to be positive 4 and negative 2. Okay? My x-intercept's positive 4, negative 2. I'm going to put that on the graph. Positive 4, negative 2. That's where he's crossing, right? And he's going to be a frowny face, right? The y-intercept, I plug 0 in for x. So I've got y equals negative 1/2, 0 minus 4, 0 plus 2. I'm plugging 0 in for the x's. Okay, so let's write this out. Negative 1/2. 0 minus 4 is negative 4. 0 plus 2 is 2. Okay, so let's figure out what this is. Am I going too fast? Yeah, just a little bit. Okay, what's half of 4? 2. And negative times negative is a positive. So this guy right here will be positive 2. And then 2 times 2 is 4. So he's going to intersect the y-axis at 4. Right here. That's his y-intercept. Okay? Now the vertex, the equation for the vertex said that I do s plus t over 2. Okay? And then for this guy, I just plug it in. I always just put plug in. Plug in. What is s and t? 4 and negative 2, right? If I'm looking at this guy, and I'm looking at these 2 points, my vertex should be exactly in the middle of those 2 points, right? Wherever that is located. So I take negative 2 plus 4, or 4 plus a negative 2, whatever you want to do, and divide that by 2. That is what? Negative 2 plus 4 is 2, divided by 2 is, you said 1? Yeah? Okay, now I want to find this y-coordinate. So I'm going to plug that back into the equation. Negative 1/2 times 1 minus 4 times 1 plus 2.
Wait, so S and T are...
S and T are your intercepts.
How do we decide what numbers?
What do you mean what numbers to plug in? The 2 and the negative 2 and the 4?
Yeah.
This guy right here? That guy is these 2 guys.
So it's going to be like 4.5.
Added together and divided by 2. So S plus T, this is these 2 added together. S and T are 4 and negative 2. I take negative 2 and add 4, and I divide by 2. Okay? And that comes out to be 1. So now I'm plugging 1 in.
Like 4.5.
Okay, so negative 1/2 times 1 minus 4 is negative 3 times positive 3. And you said you got
I got 4.5.
4.5. Is it positive or negative? Positive 4.5. So 1 comma 4.5 right there. Okay. All right, and then do you see where he's there at 4, and I can put a dot on the other 4, and he's going downhill like this and downhill like this, and that's what my parabola looks like. Okay. 4.5 because we plugged the 1 back in. This is a lot of information.
Wait, that's our
right now.
vertex? 1,
1 comma 4.5 is the vertex.
So what's the 4 for?
What do you mean? What's the 4 for? The 4 was the y-intercept. So the 3 things that we needed to find were the x-intercept, which are 4 and negative 2, the y-intercept, which is 4, and the vertex, which is 1 comma 4.5. The 4 came from the y-intercept.
Yeah, where's the 4 though? Like,
What do you mean?
on the graph.
On the graph? The
Like, are you
y-intercept?
going?
The y-intercept is 4. Put a little dot right there. Okay. So he starts at that vertex and he goes down and down. Okay? Questions? No? Okay. I think I'm going to change some of these instructions here. Example 4. Write the following functions in polynomial and x-intercept form. Okay? So, let's figure out what form each one of these is in now. So A, what form is he in? Transformation form, he is in transformation form or vertex form. So I'm going to put trans or vertex. That's what form he is in. Okay? What about B? What form is he in? He's in polynomial or what do we call it? Standard form. B is in polynomial form or standard form. C is in x-intercept form. Or we call it factored form. Okay? I don't care which one you go by, so I'm putting both. You only have to put one of them. You can either put polynomial form or standard form. I don't care. But I'm putting both now because it's your notes. Okay? So here's what I want us to do. Write the following functions in polynomial and x-intercept form. Okay? On your homework assignment, I'm going to alter the instructions. You ready? If it says put it in whatever form, you're going to change everything to polynomial form. We're going to change everything to standard form. If it is already in standard form, that double bonus. You don't have to do anything, right? So on your homework assignment, if it says change it to x-intercept form, just worry about changing everything to standard form because standard form is the main one that we use. Okay? So all of these, example 4 and example 5, we're going to change them all to standard form. Good? Okay, so B. What does that mean for B? We don't have to do anything to B. B is done. Okay, so I'm going to put A over here. We're going to change A to standard form. 0.4 times x minus 3 squared plus 2. Okay? All we have to do to this thing is we need to get it in standard form and just put it in descending order. So x squared x in number. That's what I have to start with on part A. What do I do first?
The x minus
The what? X minus 3?
squared.
Squared. Yes. We're going to FOIL this guy. So I'm going to take x minus 3 times x minus 3. Okay?
So x
Is that a
squared.
3 or a 2?
That's a 3.
Okay.
All of those are 3s. Okay? X minus 3 times x minus 3. So x minus 3 times x minus 3 when we FOIL, x squared
Squared minus 6x.
minus 3x minus another 3x, which if you can do that in your head, go ahead. It's minus 6x plus 9. Okay? So x squared minus 6x plus 9 is what that comes out to be. Okay? And then I'm going to write the stuff around it. So now I have 0.4 on the outside of that, and then a plus 2. Now what do I do? Now I have to distribute the 0.4. Blah. Okay? 0.4 times x squared, 0.4x squared, minus, sure,
Minus
0.4 times 6, 2.4. Yep, that's right. Just think of what 4 times 6 is. 4 times 6 is 24, so it's got to be 2.4. Make sense? Okay, what's 4 times 9? It's 36, so it's 3.6. Did you do that in your head?
Yeah.
Good for you. Look at that. Okay, plus 2. Oh, wait. My 2.4 needs an x. Sorry. I forgot an x on my 2.4. Make sure you put that. Okay? One more thing we can do. Combine the 3.6 and the 2. Okay? So 0.4x squared, nothing we can do with him. Minus 2.4x, nothing we can do with him. Plus 5.6. And we'll call this guy f of x. Was he f of x? Yes, f of x. We'll call him f of x again. So now he is in standard form or polynomial form.
So
That's
we don't
all
have to
we're gonna
solve it
do.
from there, we just have to-
Nope, that's it. They just want us to put it in a new form. We're changing it from whatever form it's in now to polynomial form. Okay? They want x-intercept form also, but we're not going to do that because that's a gross, ugly thing. Okay? And standard form will get you what you need to do. B, we said we got to skip. Why do we get to skip B? Because it's already in polynomial form. Okay, C is negative 2 times x minus 4 times x plus 2. Okay, we want to switch this to polynomial form. So you could distribute first if you wanted to. I'm going to worry about foiling first. I'm going to FOIL the x minus 4 and the x plus 2. Yeah, that might be the easiest way. Okay, so x minus 4 times x plus 2 is x squared plus 2x minus 4x minus 8. Okay, I'll kind of slow down a little bit. Yep, because that's the insides. Okay. X squared minus 2x minus 8 if you combine those middle two pieces. And then, are we done? No.
Now FOIL the 2.
Now I've got to distribute the negative 2 through, right? I'm going to multiply the negative 2 through the whole thing. Okay? So negative 2x squared plus 4x plus 16, and we call that guy?
Standard form.
That is in standard form. H of x. His name is H of x. And now he's in standard form. Okay? You see how that works? Okay?
I have a question.
Yes?
Why at the top is it x squared plus 2x and then in parentheses it's negative?
Oh, good question. So right here, when we FOIL these two out, we got x squared. So x times x is x squared. X times 2 is 2x. Negative 4 times x is negative 4x. And negative 4 times 2 is negative 8. But when we combine the 2x and then negative 4x, 2 minus 4 is negative 2. That make sense? Yeah?
Do you want that tote in here or in your car
I don't think I have a room for it in the trunk of my car. I'll have to put it in the main part of my car. So if you just want to put it in here, that'd be great.
I'll just bring it in. I'm gonna.
Oh, you're awesome.
Yep.
Awesome. Okay, so C is standard form. Good?
Yep.
Yeah? Okay, let's go down. This one says it wants it in transformation form, but we're going to get rid of that, and we're going to say just polynomial or standard form. Okay, anytime it says that on your homework assignment, just switch it to standard form. Okay? Because standard form is what we usually do everything out of. All right, so A. What form is A in? Oh, man, that's nice because
You don't need it.
then we don't need to do anything.
The next one's in y or x-intercept.
Okay, the next one's in x-intercept or factored form, whichever way you want to call it. I don't care. He's like broken down. So we've got to switch G of x, which is part B. Okay, so I want to switch that to standard form or polynomial form. What do you do first? FOIL. So x minus 2 times x plus 1. So x squared
Plus 1x.
plus 1x
Minus 2.
minus 2x minus 2.
You ever seen Trig?
Do I? For here?
Yeah, from this period after dinner.
Oh boy. Yes.
You spelled
I gotta
too
think
soon.
about where
This
it's
is
at.
commentary.
I can email it to you. Mm-hmm.
This is commentary. You spelled too soon. You said earlier you didn't have to touch on it.
Yeah, I haven't done it yet. Middle two pieces, add them together, x squared minus x minus 2. Okay, and then, I'm done? No, because we have to distribute the 0.3. So, 0.3 x squared minus
0.3x.
0.3x minus, what's 0.3 times 2? What's 3 times 2? Is 6, so it is 0.6, 0.6. Okay, done?
Yes.
And we call him
G of x.
G of x. Is this making sense?
Yes.
Yes? Okay. We're just trying to put him in a new form. He is now in standard form. Good? Okay? Happy with this?
Yeah.
Okay, this right here is a summary of all of the stuff that we just talked about. Okay, I'll zoom out, see if you're still writing. Transformation form, when it's in that transformation form or vertex form. Okay? The vertex is found by doing, don't worry about the x-intercept, like all that junk. Okay, you just plug, when you're doing the x-intercepts, you plug 0 in for y. Which ends up working out to look like that, but we're just going to say plug 0 in for y and figure it out. Okay? The y-intercept, you're going to plug 0 in for x for all of these. Okay? So, vertex form, polynomial form, x-intercept form. Polynomial form is standard form. Okay? When you're doing the x-intercepts when it's in standard form, they tell you to do the quadratic formula, which you can do. You can also do, like, factor it down, which we tried to do on that one example, but it didn't work. Okay? So you could factor also. If it will factor down. Okay, so try maybe factoring it first and then use the quadratic formula if it all doesn't work out. X-intercept method, your when it's broken down, S and T are just your your x-intercepts because you set them equal to 0. Like the two factored pieces equal to 0, and it ends up being your s and t. And then just plug 0 in for x to get the y-intercept. Okay? Really don't worry about all of this jumbled stuff right here if that confuses you. Just plug 0 in for x if you're trying to find the y-intercept. Plug 0 in for y if you're trying to find the x-intercept. That's all you're doing. And then just solve. Okay? So don't get bogged down with your a, s, t, s and t, blah, blah, blah. Okay? Just break this down. The things that I would remember is negative b over 2a and s plus t over 2. Those are things that I would make sure you remember. Negative b over 2a is how you find the vertex when it's in standard form. When it's in factored form, you do s plus t over 2. Okay? And then you plug in. Plug in. And plug in. There's that. Okay? Good? All right. Let's just do one of these. We'll do example 6 and we'll skip example 7 because it's going to be similar to that. Okay? Maximum area for a fixed perimeter. Find the dimensions of a rectangular field that can be enclosed with 3,000 feet of fence. Okay? What does it mean if I'm enclosing it with 3,000 feet of fence? Is that referring to the perimeter or the area? The perimeter. So we're talking about perimeter. The perimeter is 3,000. Now, given these dimensions right here, how would I find the perimeter? 3,000 is equal to what?
X plus y equals 2x.
Kind of. There's 2 x's and 2 y's, right, for the perimeter? It's x plus y plus x plus y, right?
X squared plus
Nope, it's not x squared.
2x.
It's just 2x plus 2y.
Okay.
2x plus 2y. Okay? That has the largest possible area. So I want to maximize the area. How do I find the area of this thing? X times y. Yep. Okay? So I have 2 equations going on here. I have the perimeter equation and I have my area equation, and I want to try to find the maximum. Okay? All right, so to do that, let's do some substitution in here. Let's take and solve this equation for one of the variables, x or y, and then let's plug it into the other one, okay? So do you want to get the y by itself? Sure. Okay? So if I want to get the y by itself, I'm going to kick the x to the other side. So I have 3,000 minus 2x is equal to 2y. Yeah? Okay, and then what? Divide by 2. Divide by 2, divide by 2. Okay, so y is equal to 3,000 divided by 2 is 1,500 minus x. Hey, that comes out kind of nice. 1,500 minus x. All right, then I take this y, 1,500 minus x, and I plug it in for y there. Okay, so I want to find the maximum of x times that junk. 1,500 minus x. Okay, I'll stop for just a second. Let's go ahead and distribute the x through. Okay, 1,500x minus x. I'm going to write it as negative x squared plus 1,500x. Can I do that if I flip them around? Okay, to put the x first. And I want that to be a maximum. Okay. Do you guys see what I just did?
Yeah.
I flipped those 2 around. I flipped the 1,500 and the negative x around. Okay. Now, if I graph this thing, what does it look like? It looks like an upside down parabola, right? Okay, we know it's upside down because of the minus, and we know it's a parabola because it's x squared. And it says find the maximum, okay? If I'm trying to find the maximum of that thing, what am I trying to find? I'm trying to find the high point, which is called the vertex. Okay, so it's already in polynomial form right now, right? Even though it doesn't have the third piece, it's in polynomial form. So how do I find the vertex of a polynomial? What? Nope, that is factored form. Polynomial is negative b over 2a, and then you plug it in to find the y coordinate. That's the formula. Negative b over 2a, and then you plug it in to find the formula.
Negative b is going to be negative 1,500.
Yep. Are we doing okay? Am I going too fast? No? Okay, so she said negative b. She said b was 1,500. So negative b is negative 1500 over 2 times what's a?
-1.
Negative 1. Are we okay? So negative 1500 divided by, basically this is negative 2, which is 750. Right? 750 comma something. Okay, plug it in. So negative 750 squared plus 1500 times 750. Ooh, 750. You plug it into the original equation, which is this guy.
I got 562,500.
562,500. Woo! Okay, so what is what? 750 means what? $750 is X. 562,500 is Y. So what does 750 mean? 750 is going to be this side right here. 750, 750. Does that make sense? What is the 562,500? That's not necessarily that Y. 562,000 is the maximum area. Does that make sense? How do I find this Y? I know that 1500 minus X is what Y is. So Y is also going to be 750, right? 1500 minus 750 is also 750. Did you know that if you are given dimensions for a rectangular shape, it has the maximum area when it is as square as possible? Right? Like if I know that my perimeter is, let's say, I don't know, 10. I could have this guy be a 1, a 1, a 4, and a 4. That would make 10, right? Okay? What do I want to do? Let's do 24. You don't have to write this down. Okay, let's do 24. I could have this guy be a 2, this guy be a 2, this guy be a 10, and this guy be a 10. That would make 24, right? But this guy only has an area of 20. Because 2 times 10 is 20. Okay? It is going to give me the maximum area when it is as square as possible. So what would each side have to be if it is a square and its perimeter is 24? 6. If it's a 6 by 6, the biggest area is going to be 36 that I can do with a perimeter of 24. Does that make sense? Right? Because 20 is not going to be as close to 24. If I made this, like let's say this guy is 4, that would be 8, and 8, and 8. Those guys are going to add up to be 24, but what's the area of that one? 32. Still not as big as the area if I had a 6 by 6, right? Each one of these 3 shapes that I just showed up here, all of them have a perimeter of 24. But the largest area is going to occur when you have a square happening. Does that make sense? 6 by 6 is going to give me the largest area. Okay, that's just a little way to cheat.
Can you just go back over?
Back over here?
Yeah.
Yeah? Okay, we're going to skip the last example. On your homework, make sure that you keep in mind that if it says to put it in another form, you're just converting everything to polynomial form. Okay? I'm going to alter those instructions. Just switch everything to polynomial form, because otherwise it's really gross. Okay, let me stop recording. Everybody say bye!